All right, so in this vector decomposition problem, I have this vector f, and I want to split it into components in the e hat 1 and e hat 2 directions that are defined as shown in this picture. Now, if you follow my recipe, which I encourage you to do, what we do is we construct this vector triangle over here, where the vector f, the original vector, is the hypotenuse of the triangle. Right, this piece right down there is going to be 90 degrees. And these other two sides of the triangle, they are going to be vectors which add up to f. So I have these other two vectors that are arranged in tip-to-tail fashion so that they add up to f. And these other two sides, they are parallel to the e hat 1 and the e hat 2 directions. So you notice this one right here, this one's in the e hat 1 direction, and this one is in the e hat 2 direction. And those two vectors, again, they're arranged tip to tail, so they add up to vector f. So I want to take an f and I want to arrange it into a piece that's something in the e hat 1 and something in the e hat 2. Now what I have to do is I have to find out how much in the e hat 1 and how much in the e hat 2. In other words, I have to find out the relative lengths of these sides compared to the f there. And to do that, I need to do a little bit of trigonometry, a little bit of geometry. So notice that in the problem we were given this angle theta right there. This angle theta is the angle of this sort of sloped line relative to the vertical. So therefore, if this is angle theta, then this must be angle theta right there, because this component of this side of my vector triangle, that's in parallel to the e hat 2 direction, right? So there's that angle theta. But this angle theta right there, it's not very helpful for us, because if we're going to use the trigonometry of the triangle, it has to be one of the interior angles that we're going to think about. So notice that since f here is horizontal and that reference is vertical, so if this angle right here is theta, that means this angle inside here must be 90 degrees minus theta. Ooh, and let's do a little bit of geometry here, thinking about what's going on. So if I have a right triangle, and there's my right triangle, all the angles have to add up to 90 degrees, right? So if I call this angle alpha right there and this angle right here beta, then I know that alpha plus beta plus 90 degrees, so there's this 90 degree angle right there, have to add up to 180 degrees. Now if you bring the 90 degrees back over, you'll find that alpha plus beta have to add up to 90 degrees for this right triangle. So therefore this angle right here, which is 90 degrees minus theta, plus that angle right there, those have to add up to 90 degrees. So therefore this angle right here has to be the theta, which is what I've already written in there. But that angle's theta. So that explains the rest of the stuff here, right? So notice in my answer, if I look at the component in the e hat 1 direction, that's this piece right here, that's adjacent to the angle theta. So that's why I have a f cosine theta, right? Cosine theta is the fraction of the length of the hypotenuse that's in this direction right there. So f is the length of the hypotenuse, that's the magnitude of f, times cosine theta. That'll tell me the magnitude of that side right down there. And in the e hat 2 direction, that's this piece right there. That's opposite side from the angle theta. So that's why I have an f times sine theta in the e hat 2 direction. Now we also have to be very careful about the signs, S-I-G-N-S, as well. Notice this e hat 1 component, that's this one right here. This is actually in the opposite direction of the e hat 1 basis vector. So this piece in my decomposition has to have a minus sign, because again it's in the minus e hat 1 direction. This piece of the decomposition, the piece in the e hat 2 direction, is in the positive e hat 2 direction. That's why I have a positive right there. And that explains that vector decomposition. In fact, I like it so much I'll put a little box around it. Boom, there we go, done. Actually, before we go, it's probably worth noting that when I decompose this, I went in the e hat 1 direction first and then the e hat 2 direction in constructing this vector triangle. I could have gone the other way. I could have gone in the e hat 2 direction first and then in the minus e hat 1 direction later on. In that case, I'd be working with that angle theta right there. But I'll leave it to you to determine. I'll leave it to you to check that you'll get the exact same thing if you do it this way. So it's worth trying out.